Hello, this is a video about the strategy pattern for programming. Here's the definition of the strategy pattern. It defines a family of algorithms and makes them interchangeable through encapsulation. Strategy pattern allows the algorithm vary independently from the clients. A client can use the same interface differently based on what the need is. Here's the UML. As you can see, here's the context. Basically the product that the client will be using. And this context contains different strategies. And we are using a strategy interface where we are just defining a method that then will be implemented in the concrete classes after the inheritance. Why strategy? The strategy allows the client to use the same objects differently, depending on the need. It is decoupling the behavior from the context completely. Everything is changeable, basically. To show this, let's do an example. First up, UML, calling it strategy, and let's create a class diagram called strategy here. And what I want to do is a robot, of course. Let's say I'm doing a game. I need a robot in my game. And I want multiple robots that will act differently based on what I say to them. What I want my robot to contain, first up, of course, is the name. We want to know the name of the robot. And then I want to have a behavior in it. I'm calling the class iBehavior, and then just giving the variable a name, which is strategy. Then I'll be needing some methods. First up, a constructor, because I want to add the name beforehand. A constructor with one parameter. Then what I want my robot to do is to move. The robot will be moving. And this move method is the one that will be different based on the behavior. And then what I want to do also is a set behavior. And this will take a parameter. Behavior B. There. That's basically my robot. Then I need this iBehavior data type. I'm going to use an interface. Here we go. This is some interesting stuff that this program is doing. We're going to change this at the end. My robot contains a behavior, and it can't exist without a behavior. Although we're not taking it as a parameter, so technically it can exist with a null behavior, but I don't like it, so I'll be using composition instead of an aggregation. We can have one behavior per one robot. And I'm just adding a field name there. Here we go. One robot has one behavior. Then, of course, we want to have different sort of behaviors. Gonna add 3 classes here. That will be my So first up, we want to have a defensive behavior. Then, well, of course, normal, like nothing is happening. I'm just hanging around here. And then the third will be aggressive. So I'm gonna eat you kind of action. Then I'm gonna implement all these. This is taking some time because this is not as usable as it could be. So we take a behavior and link it to a behavior. Let's make it there. On there, and then we just add this defensive behavior as well. There. So now that we have this move method here that is dependent on the behavior, of course we have to define a method that will be used when this move is called. So I'm calling it move command in this interface, which means that all of these classes implementing the interface has to contain this method. So there, that's basically it. So I have a robot that contains a strategy or behavior, and I can select which behavior I want to set. So now changing that, I'm gonna return a void. So not returning a thing. Then I just add my main class that I will be using to run this thing. Again, it did that. So I just want to add a main. An array of arguments there and making it static. And the main class is using the robot class. So there can be multiple robots, but just one main class there. And again, changing this as a void there. And now making this whole thing as a Java program. Strategy code, no main class. And here we go. So now I'll just generate the code from the UML. Pending. And here we go. So let's start with the different set of behaviors. So we have this aggressive, defensive, and normal. So we'll implement this move command differently for each of them. So let's start with the aggressive one. So just shouting something out. So nothing too complex here, but of course if you're implementing a game or something, you'd want to. This is where you make your concrete movements. So that's about the behaviors. We don't need them anymore here. We don't need the interface because it only defines this one method that doesn't have anything, any implementations. So then, of course, we want to implement our robot. So this is pretty straightforward. So in the constructor, we just want to put the parameter into the private variable. If we are setting a behavior, then our strategy will be the parameter again, quite simple. And then when we're calling move, we are taking the strategy that we contain here and we're calling the move command. So with this method, we are masking this behavior completely and this method name completely from the user. The user is only calling move. But what we're actually doing, we're taking a strategy and using move command. However, not that complex. So how about we do something with this? So first up, let's create 3 different robots. And I'll be using robot R1, R2, and R3 with separate names, Big Robot, George, and R2. Then I want to set the behaviors for each of them. So it appears there is a typo somewhere. Let's see. So just one extra S, apparently. So no problem there. Then what we want to do is just telling each of them to move. Simple as that. There. And then just run it, select the main class, and here we go. So Mr. R1 moving defensively, R2 just moving, and R3 going apeshit. And of course we could set each of these behaviors now for each of these robots again and move again. So we can change the strategy as we want and as we see fit. So that's basically everything about the strategy pattern.